In part A, we determine the net displacement of the particle over the interval 1, comma 6. So to determine the net displacement, we need the position function. So I'm going to write down this position function. So this is basically the integral of the velocity function. So we have to integrate this velocity function. And when we integrate the velocity function, we get the position function. So let me replace the velocity function as given over here, which is t squared minus 2t minus 8 dt. So let's integrate each term one by one. So first we integrate this t squared. We can use the power rule of integral. And when we do that, integral of t squared is t raised to the power of 2 plus 1 over 2 plus 1. That is, we can use the power rule. We can recall the power rule, that is when we integrate x raised to the power of n, this equals x raised to the power of n plus 1 over the same number n plus 1. So we have used this power rule of integration, and we then have this minus, and let's integrate this next term, which is negative 2t. Since 2 is a constant, we keep the constant as it is and then integrate only the t. So here also we can use the power rule of integral, that is we consider t as t raised to the power of 1, and then when we use the power rule of integral, we get t raised to the power of 1 plus 1 divided by 1 plus 1. So which I'm going to put over here. This is like this. I'm sorry, this is negative. We then have negative 8. Uh, Integral of a constant is 1. So we say that integral of a constant is the variable. So we have to put 8 times of t. So now let's get this simplified. So this becomes 2 plus 1 is 3. So therefore t raised to the power of 3 divided by the same number 3. And then this is 2 times of t square divided by the same number 2 minus 80. We cancel this 2. So we can write this in simplified form. That is t cube by 3 minus t squared minus 80. So this is the function which represents the position function. Now we can calculate the net displacement of the particle over the interval 1, comma 6 using this position function. So let's see how to find the net displacement. So basically we have to find the change in position from 1 to 6 seconds. So we write net displacement. I write down this shortly as displacement. So this equals change in position when t equal to 6 seconds, that is s of 6 minus s of 1, change position of the particle when t equal to 1 seconds. Okay. So and basically this is absolute value. We have to take the absolute value so that we get the net displacement. So let's calculate this. We have to first define the s of 6 by replacing t as 6 into this function s of t. So when I do that, I get 6 cube over 3 minus of this is 6 squared minus 8 times of t, which is 8 times of 6. So I calculated this s of 6 minus, now I calculate s of 1 by replacing t by 1. So therefore this becomes 1 cube by 3 minus of 1 squared minus 8 times of 1. Let's simplify and evaluate this. So this equals 6 cube is 216, and 216 divided by 3 is 72. So this is 72 minus 6 squared is 36 minus 8 times of 6 is 48 minus 1 cube by 3 is 1 over 3 minus this is 1 and this is negative 8, that is negative 1, negative 8 is negative 9. We further evaluate this. So this is 72 minus 36 is 36, and 36 minus 48 is negative 12. And then we have negative 1 by 3 and positive 9. So let's evaluate this. This is negative 9 plus, I'm sorry, negative 12 plus 9 is negative 3. And then we have negative 1 by 3. In this, we have to take the absolute value. So when we simplify this fraction, we get negative 10 over 3. That is inside the absolute value. And the absolute value of negative 10 over 3 is positive 10 over 3. And this is approximately 3.33 meters. So we found the displacement of the particle over the interval 1, comma 6, which is 3.33 meters. We will now answer part B, that is, we have to determine the total distance traveled by the particle in the same interval, that is, in the interval 1, comma 6. So to find the total distance, we have to first determine whether the particle changes the direction in this interval. And mathematically, when the particle changes the direction, we say that the velocity is zero when it is changing the direction. So first we set up velocity equals to zero and determine the corresponding time. So let's do this. I'm going to replace v of t equal to 0 here. So therefore this equation becomes 0 equals t squared minus 2t minus 8. Now let's factorize this. We have 0 here. I can write down this as a product of linear terms as t minus 4 times of t plus 2. So this gives two values of t, that is t minus 4 equals 0, and this implies t equals 4. This is one time, and t plus 2 equals 0, and this gives the value of t equals negative 2. But negative 2 does not lie in this interval, so we can ignore this time t equal to negative 2. So now we understand that at the time t equal to 4 seconds, the particle changes direction. So let's put this on the number line. I'm going to create a number line for the interval 1 to 6. So here it is 1, and this is when t equal to 4 seconds, and this is t equal to 6 seconds. Now we will understand the sign of the velocity. So between this interval 1 to 4, let's understand what direction the particle is moving, whether it is moving to the right or to the left. So for this, we could take any random values within this interval. I'm going to take t equal to 3 and plug it into this velocity function. That is, we have a velocity when factorized, we get t minus 4 times of t plus 2. Then I'm going to put t equal to 3 into this. So this gives 3 minus 4 is negative 1, and 3 plus 2 equals positive 5. So this is negative 1 times of positive 5, which is basically a negative quantity. We just need to understand the sign of this when we plug in this corresponding t. So in this interval, the velocity is negative, which means it is moving towards the left. So we can say that from 1 to 4 seconds, it is moving towards left. Now let's take some random values between the interval 4 to 6 so that we will understand the sign of the velocity. For that, I'm going to plug in t equal to 5 into the velocity function. So when I do that, we have this expression t minus 4 times of t plus 2. So this basically represents the velocity. So when you plug t equal to 5, we get 5 minus 4 times of 5 plus 2. So let's understand the sign. This is positive 1 and this is positive 7. So this is basically a positive quantity. So we can see that this is positive from t equal to 4 to 6 seconds, which means it is moving towards the right direction. So now I'm going to write down or draw the velocity, draw the direction of the particle. Uh, so let me put 1 over here. I'm just going to put 1. This is t equal to 1. From 1 to 4, it is moving towards the left. So we can represent like this. It is moving towards the 4 to the left. So this 1 represents this is t equal to 1 second. And when the object is over here, that is t equal to 4 seconds. And we already figured out that when t equal to 4 seconds, it changes the direction. So now it is changing and it is moving towards the right as we have figured out in this sign diagram. So we can see that it is moving like this. So this is from t equal to 4 to this is t equal to 6. I should just erase this and draw it like this. So this is how it moves. So we know that we can calculate the distance between the interval 1 to 4. We have to calculate one distance. Let's say this distance is t1, and from t equal to 4 to 6 seconds, it has moved a certain distance. And we see that this distance is d2. So basically, we have to determine the distance d1 and d2 and add those two distances, which gives the total distance. So let's find the distance. So the distance d1 is basically the absolute value of the change in position of the particle from t equal to 1 to t equal to 4 seconds. So we can write down this as s of 4 minus s of 1, and we take its absolute value. So let's calculate this. I'm going to use this s of t, that is s of t function, which we already figured out, which is s of t equals t cube by 3 minus of t squared minus 8t. So we will now calculate, or we will find this s of 4. So I put this absolute value. S of 4 is replacing t by 4. So therefore this gives 4 cube by 3 minus 4 squared minus 8 times of 4. This is the expression for s of 4 minus of s of 1, which is 1 cube by 3 minus 1 squared minus 8 times of 1. We simplify this using the calculator. We will get some value inside the absolute value. And finally, we take its absolute value. If it comes negative, we have to take the positive. So therefore, when we plug this into this expression, finally we get the distance as 18 meter. So we determine the distance t1, which is 18 meters. Now, in the same way, we have to calculate the distance d2, which is the change in position from of the particle from t equal to 4 to t equal to 6 seconds. So let's calculate this once again using the position function. So d2 equals s6 minus s of 4, and we take its absolute value. So therefore, this becomes s of 6 is 6 cube by 3 minus of 6 squared minus 8 times of 6. This is for s of 6 minus s of 4 is 4 cube by 3 minus 4 squared minus 8 times of 4. This is absolute value. So once again, we can use the calculator. We simplified these numbers, that is 6 squared is 36 and 8 times 6 is 48, which we already did in part A. So I'm going to give the final answer as, after we calculate this using the calculator, we approximately get 14.67, and this is in meters. So this is the distance traveled by the particle from t equal to 4 to 6 seconds. Now we have to determine the total distance, which is we have to add the distance d1 and d2. So therefore we see that total distance, this equals d1 plus d2. Now let's replace this d1. Since both are absolute values, we figured out d1 equals 18 meters. This is d1. So we put 18 plus d2 is approximately 14.67 meters. So when we add these two, we get approximately 32.67 meters. So therefore, the total distance traveled by the particle in the same interval, that is from t equal to 1 to t equal to 6 seconds, is 32.67 meters.